So last class we have seen till string concatenation operator, and today we'll see assignment operator, and the operator is this one. Okay. For assignment operator, we need two operand. So it is a binary operator. Operand 1, assignment operator, operand 2. Okay. And this is the assignment operator. Two operand is required, operand 1 and operand 2. So it is a binary operator. And operand 1 must be a variable. Okay. This one must be a variable. And operand 2 can be a value, can be another variable, can be an expression also. If it is an expression, expression will be evaluated and the result will be stored into operand 1. So operand 1 must be a variable. Operand 2 operand 2 can be a variable, can be a value, or can be an expression. If it is an expression, expression will be evaluated and will be stored into operand 1. Okay. The assignment operator means it should be like this. Operand 1 is going to assign into operand 1. Assignment 2, operand 2 is going to store into operand 1. So operand 1 must be a variable. At operand 2 can be a value, can be a variable, and can be an expression. If it is an expression, expression will be evaluated and the result will be stored into operand 1. For example, you can say int a is a variable and a you are assigning to 20. So this is a value. This is the assignment operator. This will store 20 into a. A is the memory location, right? Or it can be an expression 20 plus 10. Then 10 will be evaluated and the result will be stored into the memory A. Or you can say like this, int b is a variable and b is equal to a. Then a result will be stored into b. Currently a is having 30, 30 will be stored into b. But reverse is not okay. B will never going to store into a, okay? This is not okay. Assignment operator, right side value or variable or the expression will be stored into left side variable. So this must be a variable. You cannot say like this that 10 is equal to b. Not okay. B cannot be stored into 10 because 10 is not a memory, it is a value. It is a literal. So this expression is not okay. Okay. So this is an assignment operator. But when you are using an assignment operator, we have already discussed so many times, the value which you are going to store into the variable, which you will store into the variable, must be assignment computable, okay? If we say like this, int some x and assigning a value 99. Then x is a variable of type int and 99 is the integral value. So this can be assigned into this. X is the memory location. This is x and the value is 99. Okay. Because this memory is of integral type. But if we say boolean b is equal to 99, then this assigning is not okay. 99 is an integral value, and B is a Boolean variable. So this is this you cannot store into B. 99 cannot be stored into B. Means when you are using assignment operator, operand 1 and operand 2 must be of same type, or it should be assignment compatible. It should be assignment compatible, otherwise it should be same type. So X is of type int, 99 is of integral type, it is exactly same type. But if we say byte B is equal to 99, then 99 is integer type, default type is into this is byte type, not exactly same, but this is assignment compatible to B. Int is assignment compatible to B, byte type. Similarly, if we say float F is equal to 99, 99 is of integral type, F is of float type, not exactly same type, but this is assignment compatible to F. This is okay. But say I am a Boolean variable. I have a Boolean variable, some AB, and the value which I am storing into this is an expression. Expression has to be evaluated and result should store into AB. So the expression I am giving is 10 greater than 20. This is 10 greater than 20 will give either true or false. It will evaluate first. So after evaluating this, you will get a true or false. True or false is a Boolean type literal. AB is a Boolean type variable. So this result can be stored into this. It is exactly same type. So remember the point. Operand 1 and operand 2 should be assignment compatible, or it should be exactly same type when you are using assignment operator. So these things you should take care. So now let us take some example. I'll take a test. So test 25 .java. Int a is equal to 10. Assignment operator a is compatible, so this should be fine, no issue. And you can say here a, this is fine. Or b is byte type, byte type 99. This is not exact type, but it is integral type, assignment compatible. So this is B. This also should be fine. Compile this and execute test 25. It is okay. Test 25. Right. But if I say something like this, 10 is equal to 10 assignment operator 99. This is not a variable. This must be a variable we have seen. But if I compile this now, again test 25, unexpected type, required a variable but found a value. Which one? 10. So this is unexpected type. This should be a variable, but it is found as a value, literal. Though this is not okay. So this is the error message here, unexpected type. This is not okay. Similarly, if we take something like this, string str is equal to say 88. So 88 is of type integral, str is of type this, so this should not be okay. Compile again. Incompatible type. Int cannot be assigned to string. This is integer value and you are trying to assign to string type. So this is also not okay. It should be same type or it should be assignment compatible. If we take like this, int x is equal to 10 greater than 20. So after this is an expression has to be evaluated, and after that you will get a true or false. True or false is a Boolean value and variable is of type integral. Again, assignment incompatible. Compile it. Incompatible type. Boolean cannot be stored into int. So this is not okay. But if we take Boolean AB is equal to 10 greater than 20, and I'll print this result also. AB. Save it and compile. Compilation okay, execute test 25. Right? It is false. So this is assignment operator, but it has a problem. For example, what happens is, so we have operand 1, byte b is equal to 10. 10 is by default int type, and this is of byte type. It is not exactly same, but it is assignment compatible. Now, how it stores actually? This 10 is of type int. It actually converts this 10 to byte type and then it stores it into B. It has to convert first. Assignment compatible in the sense it has to be converted. And when you are converting, it should be convertible. For example, if I say B is equal to true, B is of type byte, true is of type Boolean. True cannot be converted to byte type. So it is not convertible at all. So it is not compatible. Compatible in the sense the value should be convertible to the, this is a source type, this is source, and B is destination type. Source type should be convertible to destination type, then it will be assignment compatible. Now source is true, which is of Boolean, B is of type byte, so it is not convertible at all. It is not convertible, so incompatible. You cannot convert also. Now remember the point here, when 10 is of type int and storing into byte, it internally converts automatically and stores into byte type. It is convertible, so it is converting internally. But we have seen one example. Suppose int x is equal to 10 and byte b is equal to x, then this is an error. But you notice x value is 10. 10 I am storing into byte, it is an error. But when I'm writing directly 10, if I directly write byte b is equal to 10, then this statement is valid, but this is invalid. Why it is so? Because in this case 10 is constant. 10 is not going to change. It is always 10 only, no chance to change. And it is within the range of byte. It is integer type. It is int. It is constant. And it is convertible. So all three condition matching, directly 10 is storing into this. What is happening in this? This is int. This is not constant, and convertible. Convertible but not constant. So it is giving the error. So what we can do, we can declare it final. We can declare it final. If it is final, it is constant, it is within the range of byte, and it is convertible. So it is directly converting and storing into this. What if int x is equal to 300 and byte b is equal to x? It is convertible, it is int, it is not constant, but convertible. But not within the range. Not within range. It is not constant. Okay, so I will solve this first. I will declare it as final. Final means it is constant, but another problem, it is not within the range. So if you convert also to byte type, this is out of range. 300 cannot be stored into byte. So it will not convert. If you convert, it is not okay. But this conversion is fine. 10 is within the range. It is constant and it is convertible. So it will automatically convert into this type and it will store. But it is integer type convertible, not constant. We declared as final. Now it is constant. Convertible is also okay, but not within the range. If it is not within the range, it will not convert. Again, it will give an error. So what you have to do in this case, you have to convert explicitly. You convert is when it is possible, only when it is not within the range. Other condition must match. Okay, it should be constant, it should be computable type, and if it is not only within the range, then you convert. If it is within the range, it will be converted automatically. This will be converted automatically. So this conversion is called implicit. This conversion is implicit conversion. Implicit conversion, and when you are converting, that is called explicit. Explicit conversion. Okay, so two types of conversion, implicit and explicit. When it is implicit, when automatically converts, you are not doing anything, it will be converted automatically. This is implicit conversion. When you have to convert, that is explicit conversion. In both the condition, the value must be convertible. It should be assignment computable, it should be constant, and if it is within the range, then implicit conversion. If it is not within the range, then you have to convert, that is explicit conversion. This is called typecasting. This conversion, either implicit or explicit, that is called typecasting. So two types of typecasting, implicit typecasting and explicit typecasting. Implicit typecasting is when JVM is converting automatically, you no need to do anything. That is implicit typecasting. Explicit typecasting is when you are converting explicitly, you are doing it. That is explicit typecasting. Both implicit and explicit typecasting is possible only when value is convertible, means computable. Value is computable, then only typecasting is possible. But if the value is within the range and it is constant, it will be converted automatically, implicit. If the value is not constant, not final, not constant, not within the range, then you have to convert explicitly. Okay, remember these points. So two types of typecasting. Typecasting when it is required. When typecasting is required, when source type and destination type not same, then typecasting is required. This is not same. When source and destination is not same, typecasting is required. Typecasting can be done in two ways, implicit or explicit. Implicit is value is constant within the range, implicit typecasting. Value is not constant, not within the range, explicit typecasting. But it should be convertible, means it should be assignment compatible, not exactly same. But if suppose boolean b is equal to true, and I am saying byte x is equal to b, implicit and explicit, both the typecasting is not possible in this. You cannot convert because this is not assignment compatible. This is not compatible type. Typecasting is also not possible in this case. Okay. So now let us take an example. Set test 26 .java, and this is test 26. Byte b is equal to 10. It is fine, no problem. 10 is of type int, b is of type byte. It will be converted implicit typecasting. Okay, but int x is equal to 10 or 20 and sort s h is equal to x, not okay. It will not be converted because it is not constant. Okay, and not within the range. Compile test 26. This cannot find symbol. X cannot find symbol. Why? Int x is 20. This should be right. Save it. Not AB, it is SH. Compile. Possibly logic of conversion from int to short. When you are converting this, this statement. So this is okay. But what we can do is, we can SH is x, but x should be constant. It is constant. Now compile. Okay. And execute. Sorry, it is test 26, right? And execute test 26. So this is okay, 20, converting, right? It is converting because it is final. Now if I do like this, int AB is equal to 300 and byte I is equal to AB. I'm storing byte I is equal to AB. So this will not happen. It is not implicit. This is implicit because it is constant. It is within the range. This is not okay because it is not constant. So what I'll do is I'll make it final. Now it is constant. Now if I try this and print I, what will happen? Test 26. I missed termination. Test 26 is still not okay. Incompatible and possibly lossy conversion from int to byte. So this statement is not okay. It is final, but it's still not possible because it is out of range. So what you have to do in explicitly byte type. So in a braces, you have to put byte. Now it will work fine, but the output will not be same. Compile and test 26. It is 44. It is converting no error. This is converting no error, but it is becoming 44. How it is becoming 44? Forcefully you are converting, okay? This is forcefully you are converting. This one. But this one was not forcefully. It is okay, and it was within the range. So this was fine. If it is constant within the range, it will convert implicitly. It is constant not within the range. You have to convert explicitly. When you are converting explicitly in a braces, you have to mention the destination type like this, and it will be converted. And it is working fine, but the result is 44. How come result is 44? Will come to little later. If you say like this, another example you take, Boolean sum j is equal to true and byte k is equal to j. It will not convert anyway. It is not convertible. So I'll make it final. Okay. After final, explicitly you have to do, I'm saying byte. Right. Now you see what happens. Boolean cannot be converted to byte. You cannot convert. This type of conversion is not okay. It should be assignment computable. Then only you can convert explicitly. Otherwise, explicitly also not possible. Boolean cannot be converted to byte. So this is not okay, but fine. Now we understood if the value is constant and convertible and within the range, it will have implicit conversion. If the value is out of range and constant and convertible, explicitly you have to do. If the value is not at all convertible, explicitly, implicitly, both is not possible. Right? So this is what we came to know, implicit and explicit conversion, typecasting. But now question is how it is becoming 300 to 44. 300 integer type. So we have a memory A which is having 300. How memory will be? Internally, the memory 4 bytes of memory will be in this way. Assume this is from 0 to 23 bits. Sorry, 31, right? 32 bits, 4 bytes. So it goes like this. Fit like this, 32, okay? And 300 I'm storing in this, 300. And 300, if you convert into binary format, this value would be some 0, 0, 1, 0 0 1 1 0 0. This is 300 binary format. So this has to fill into this A. It will be like this 0 0 1 1 0 0 1 0 0. The remaining all will be filled with 0. Remaining all will be filled with 0. And 0 and sign bit, so this is also 0. What we are doing, we are saying here, sorry, this is not B, I is forcefully converting byte to A, like this. 300, we are converting this AB actually, right? AB, converting AB, like this. So now what you do, when you say I like this, I is of 8 bits of memory. 8. 0 index 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. This is not there actually, okay? Till this 8. So now when you do like this AB has to store into this. This has to store into this. How it will store? 24, 34, 32. 32 bits of data has to be stored into 8 bits. It is 7, 0 to 7, 0 to 7, 6, 5, 4, 3, 2, 1, and 0, right? So when you do like this conversion, 8 bits of data from here from last 8 bits of data will be copied and will be stored into this. And after copying whatever data is there in this, that will be the result. So from here 8 bits, this is 1, 2, 3, 4, 5, 6, 7, and 8. This data will be copied and will be pasted into this. So it will become 0, 0, 1, 1, 0, 0, 1, and 0. So this is the byte data. This is I. This is what I becomes. Now after that, if you convert this value to integral format, this becomes 44. This is what implicit conversion. And this is what it is saying, possibly lose the conversion from data when into short. Means what? This many data we are losing. If it is having some value in this current date is 0, this data will lose. We'll lose this data after conversion. We will get last 8 bits of data only will be copied into this and will be stored. So after conversion, if this bit by chance becomes 1, this complete result becomes negative. Okay, this complete become negative. So this is what implicit explicit conversion, how it converts. Explicit conversion, when you do forcefully out of range value, because of this reason it becomes like this. I hope you understood this clearly. Try this at your home. So this is what explicit typecasting. Next is assume in reverse order. In this example only I'll take. Say I have byte B, byte MN is 89 and int ij is mn. Okay, if we do like this, and if I print mn also, sorry, ij, save and compile. Execute. 26. So it is 89, no problem in this. What happens in this? This means byte data you are storing into it, int. 8 bits, 1 byte of data, 8 bits of data you are storing into 34 bits. So there is no chance to lose anything, no chance to do anything. So when lower type to higher type, when you are converting, you no need to convert, it will be always implicit and no chance to lose anything. But when you convert higher type to lower type, there is always a chance to lose something. In this case we are losing, but here we are not losing. Why we are not losing? Because the value is within the range. Sorry, not this one, this one. Value is within the range. 20 will be stored into this short. It is lower type, but okay, it is not going to lose anything because the value is constant and it is within the range. So remember, when you are converting from higher type to lower type, there is a chance that you can lose something because the conversion will be like this, like this. But when you are converting lower type to higher type, no chance to lose anything, and it will be always implicit. When you are doing higher type to lower type, it should be explicit. It will be implicit only when it is constant and within the range. It will be implicit. Otherwise, you have to do explicitly. But when you are doing explicitly, chance is there that you may lose something. So again, implicit and explicit, you can say two types. Typecasting, again, two types. That is widening and narrowing. Widening and narrowing. Widening means you are increasing the size. Narrowing means you are reducing the size. So when you are converting from lower to higher, it is widening. Narrowing is higher to lower. It is narrowing. Okay. Widening and narrowing. Widening is lower to higher. Narrowing is higher to lower. So this one is narrowing. Sorry, widening because it is lower to higher, and this one is widening because it is. This one is narrowing because it is higher to lower. Widening and narrowing. So these two types of typecasting. Implicit, explicit. And remember another thing, you can say like this. Say we have byte to short to int to long to float to double. All these order will be widening. If you come reverse, that will be narrowing. Okay. And this type of conversion is possible because all is of integral type. Okay. In between, you can say here like this also. Char can be converted to int. It will take the ASCII value. Okay. But int to char, if you do, explicitly you have to do. Again, that will be narrowing. Right. So, and remember, conversion is possible only when it is computable type. So this is implicit, explicit, widening, narrowing, and typecasting, and how it works internally when you convert a higher type to lower type. Remember, these last bits will be converted into this way. Now, if you take another example, say test 27. And in this, byte b is equal to 10, b is 10, or a is 10, again byte b is equal to say 10, 20 and 10, and byte c is a plus b, and print c, test 27, compile it, test 27.java. It is an error. Okay, this is the error. Possibly loss of conversion. Why it is so? Both is of type byte, but still an issue. It is not converting int to byte. Where is int? No int in this. We have seen arithmetic operator. Any one operand or both the operand is int or lower than int. Result type will be int. So this result type is int, and int cannot be stored into this directly. These are not constant, and this is not within the range also. Because a variable, it may be out of range sometime. So what you have to do? You have to say byte. Now still an issue. What is still issue? Compile it. Still error. Same error. Okay, it's still same error. Why still same error? When you say byte, this only a is converting to byte. Okay, let us convert b also. B. Now you save and compile. It's still same error. It's still same error. Now why is still same error? Because you are converting a to byte, b to byte, and byte result is int. It's still the same thing. What was previously like this? This is the same thing. So now what you have to do in this case, you add the result first. A, B, do the addition, and the result converting to byte type. Now this is okay, and you will get the result 30. Compile and execute. Test 27. Now it is okay, 30. Now this is fine. Take another example. Suppose okay, I have already here a, and a if I store into some integer type, int I is equal to a. This is okay, right? No issue. Compile. It is compiling fine, no problem, because it is widening a to I, widening by byte to int. That is okay. What if this, if I do explicitly, int explicitly, if I do, this is also okay, no problem. This can be implicit. If you are not doing, that is also okay. If you do, that is also fine. That is okay, no problem. Okay, explicitly also you can do, but not required at all. Next is, suppose I have char ch is a. Now I is ch, and I'm printing I. Ch is a character and I is int, and I'm printing character to I. Now what will happen? You check. Test 27. That is okay. Execute. Test 27. 65. ASCII value is storing. Okay. Character will not store. Corresponding integral representation of that character is going to store into I. So this is how it works. Next, reverse you take. Int j is equal to 65 and char ab is j. Now you check. Compile. Not okay. Possibly lose a connection because it is higher type. J is higher type. This is not okay. Convert explicitly. Char. Now you check and print the ch also. Sorry, AB. Print AB. and execute. Now printing A. Okay. So ASCII value is going to store into Sage, but ASCII value directly cannot store. It should be constant within the range. Otherwise, you should do explicit conversion. Okay. So this is conversion, or you take another example. Float F is equal to something like this. Okay, this will be an error because by default double. So I'll add one F at last. Now it is okay. And if I convert to int ij is equal to F, check it. Sorry, compile. This is not okay. Float cannot be stored. Okay, so I'll do explicitly int explicitly and printing ij also. Ij. Now you compile and execute. Compile, okay, and execute. Test 27. Java. So it is 1, 2, 4. How come? Means only this part it is taking. Okay, in this conversion it is taking only this part. So this is the assignment operator and typecasting. Assignment operator and typecasting. You can have some compound assignment operator also. For example, int k is equal to 90, and you can say like this: k plus is equal to 9. So how this evaluates is compound. This is compound assignment operator. Okay, how this evaluates is k is equal to k plus 9. So this should be 99, and you print k, you get 99. Compile and execute. 99. Okay, so this is compound assignment. You can form any arithmetic assignment operator on any logical compound assignment operator. You can form. Okay, all the operators what we have seen so far, you can form compound with the assignment operators, and that will be compound assignment operator. Okay, any questions so far? No question, right? So today we have seen only assignment operator, and today we'll stop here. If no question, if you have any question, you can ask, or you can ask in next class also. No question, right? Okay, so we'll stop here today, guys. Thank you so much. Bye bye.